Hello, hello. It is beautiful in the city of Chicago. If you don't know who I am, my name is Miss Felicia, and I am your math maven. And I am here to shine a spotlight on the standards for mathematical practice. I'm going to say it every time I'm on here. The standards for mathematical practice, known as the S&Ps, they are the cheat code for not just the state tests, but also how to make sure our students are critical thinkers and also able to analyze any kind of situation in the classroom as well as real life. They are the cheat codes to that. And so I am here today to talk about standards for mathematical practice number 2. In a previous video, I talked about S&P 1, which is all about solving problems, make sense of problems, and persevere in solving them. If you want to get more information about that, my previous video posted that, so please make sure to watch it. But today, we're going to talk about standards for mathematical practice number 2, which is reason abstractly and quantitatively. So, I have a question for you. When you think about abstract thinking and quantitative thinking, what comes to mind? You know, two things come to mind for me when I think about abstract. One is in a math context and one is not. The math context, I think about like numbers floating around in my head, thinking about just numbers without a particular context, right? I also think about abstract art from Humanities 101 in high school, when we would study different artists and their paintings or their sketches, and they were labeled an abstract painting. We were always trying to figure out what was the message that the artist was trying to convey. And so I think about both of those when I think about abstract. Now, on the other hand, when I think about quantitative, I think more about a real life scenario. For example, I'm going to dinner, 5 of us going to dinner, we're going to split the bill. How much would each person have to pay? Or I'm going to treat some of my friends to a concert and the tickets cost X amount. How much would I have to pay in total? So those are two examples of abstract thinking and quantitative thinking. But when you think about it, you need both. Strong mathematicians, which includes our beautiful students, strong mathematicians have to be flexible and think about both. They have to think abstractly as well as quantitatively. And that is the power of standards mathematical practice too, because it elevates both. So let's take a scenario, shall we? Let's take a real life scenario. There is, I hope this is real life. I'm going to purchase 3 packs of gum, and each gum costs $2. Each pack of gum, I should say, costs, to be specific, each pack of gum costs $2. So how much would I have to pay? Well, quantitatively thinking, I say, okay, I have 3 packs of gum. 1 pack costs $2. So I'm buying 3 of them. So I can do 2, 2, which gives me $6, or I could say 3 times 2 equals 6. Abstractly, I'm simply thinking about the equation. What is the equation I need to solve? But as you can see, you need both. I have to flip it back to the context and make sure my answer makes sense. Because if I'm purchasing 3 and I get some kind of other answer and they cost $2 each, and I get the answer of 2, well, does that really make sense in terms of the context of the problem? Or if I'm adding 3 plus 2, does that make sense in what the context of the problem is asking me to do? That's one example. So again, you can see the flexibility, I hope, in both of that, in that type of task. Another task could be, we're celebrating a birthday, and shout out to all the August birthdays. I can't wait till March, but shout out to all the August birthdays out there. It's a party, and I'm gonna buy 8 balloons, and each balloon costs $1.25. So how much would I have to spend for 8 balloons, not counting tax? So my answer, I'm thinking quantitatively, okay, I have 8 balloons. Each balloon costs $1.25. I have 8 of them I'm going to purchase, so I'm going to multiply 8 times $1.25 to get my answer. The abstract part is simply the actual writing of that equation. But again, I have to think of quantitative reasoning because I have to, again, situate it back into the task. Why wouldn't my answer be $8? Well, and why does 10 make sense? Well, each balloon is a little bit more than $1, so I know it's going to be greater than 8. So $10 would probably, it does make sense. All right, so those are just 2 examples. The second one was pretty much a 5th grade task, just to give you a little bit more context. But so you want to make sure that our kids are participating and engaging and being flexible in both, because when you do that, that's also a cautionary tale about keywords, right? Because sometimes, so in that case, difference, and when we think about keywords, it doesn't always mean what we say it means. It really depends on the context. For example, each does not mean divide, because we did not divide in the first task. Difference does not always mean subtraction. Total does not always mean addition. So a key word, I'm not saying they're all bad, but you have to put it in the context. I hope this makes sense. If not, if you have any questions, just ask. I'm here to support you as we support one another. And again, we always want to make sure that our lessons are always engaging and interactive among students, that we make yesterday's lesson jealous. Have a great afternoon.